29 international conferences in India and abroad as organizing chair and corresponding editor over more than 47 book volumes from Springer, LNCS, AISC, LNEE, and SIST series. He is quite active in research in the areas of swarm intelligence, machine learning, data mining. More than 70 PG projects are supervised by him. Currently, 8 scholars are pursuing PhD under him. His first PhD scholar got her PhD degree with gold medal from her university for the outstanding work done by her in the areas of swarm intelligence optimization. He has over 150 research articles in various journals with SCI impact factors, Scopus index, and also in conference proceeding of Springer, IEEE, etc. He has delivered number of keynote address and tutorials in this area of his expertise in various events in India and abroad. He has research collaboration with NTU Singapore, University of Leicester, UK, Dayton University, Vietnam, and many universities of US, Taiwan, Japan, Malaysia, etc. He is also visiting faculty of University of Leicester, Dayton University, etc. Currently, he is in editorial board of IGI Global, Indoor Science, Growing Science Journals, Springer, AJ, SE, etc. He is the developer of a new evolutionary optimization technique called SGO and SCLO. He was recipient of Leadership in Academic Award by SOCHM in the year 2017. Now, with this note, I'd like to request Shatpati sir to start his deliberation.
Yeah, thank you, ma'am. Thank you, Ranjita, ma'am. Good morning and namaskar to all the participants on this Atal FDP organized by Department of Computer Science and IIT Mizoram. I hope I am audible to all of you. If it is okay, someone can just indicate me your voice is clear, then I
Yes,
can go
Yes,
ahead.
sir. Yes, sir.
sir, your
Voice is
voice is
clear.
Thank you very much. First of all, I express my profound thanks to the director of the NIT Mizoram, a very good friend of mine, Dr. Rajat Gupta, and also Dr. Ranjita Das, the head of the Department of Computer Science of the NIT Mizoram, for having invited me, having made me a part of this beautiful 5-6 days Atal FDP program on a very good topic. Equally, I am very happy to really excited to meet my old colleague, Mr. Vijay Kumar. After a long time, I guess about 2.5 years almost, I left that institution. And then today online, it was a pleasant surprise for me. And I really thank Ranjita ma'am for giving me this opportunity on this pandemic time when people are physically disconnected, but we are digitally connected with our old friends and colleagues. And equally, this is a big opportunity for me that I'm delivering or meeting many of our friends and colleagues across India. And I was given to understand by Ranjita ma'am that there are about 150 participants and already 40 plus are available, and others might join in due course of the time when they are comfortable. So it's really a great opportunity the pandemic COVID has given to the society. You know, everybody they say COVID has created lot of havoc, but I find the COVID has created lot of opportunities. And I just wish that every one of you are safe, your parents and your relations, your colony members, your friends are really safe, and none of you have any kind of difficulties during the pandemic time. Even if you might have faced the difficulties, you might have definitely defeated the virus like I did in the month of October, being seriously ill and hospitalized on oxygen, and then with the sheer willpower and determination coming out of the pandemic situation very well, and keeping myself very healthy and fit and having a new lease of life. So this is a big opportunity pandemic has given, and probably you must be knowing that during this time, last couple of months, everywhere, several parts of India, we are having this Atal FDP, thanks to the ICT, thanks to the government of India, thanks to the ministers, ministry, those who have come out with a beautiful program like Atal FDP, and we are all trying to communicate each other, trying to know from each other. With this, we sing and meeting, welcoming to all of you. Let's proceed with the purpose for which we are all gathered today digitally. I understand that already 3 4 days, yeah, 3 days. I guess 3 days program already over. The talks been over, and immensely the colleagues must have been benefited by the delivery by the different experts. And today, Ranjita ma'am has given a responsibility of carrying out or making you learn. In fact, I will not say making you learn, rather sharing some information about the two topic which she has chosen for me. One is neural network, and other one is deep learning. Those are the very fancy terms today, like machine learning or neural network or deep learning. Most of us are easily carried away by the fancy terms, and many of us must be working, many of us must be guiding, many of us must have published a lot of papers, and many of us must be actively involved in the research in this domain. So I understand, I was given to understand by Ranjita ma'am that I must be very fundamental in my talk, because the conglomeration, the group is a heterogeneous, and I was given to understand that different streams of the colleagues are here, and so it would be better if I go fundamental and go slow and go solid. So on that account, I have made my presentation ready, and since it is a digital platform, and first time, honestly, I'm delivering my talk through Google Meet, since I prefer Zoom, but I understand the institution NIT Mizoram, they are little skeptical about the Zoom because of the security issues, quite rightly. So I have to go by, I have to adhere to their norms. So I said, fine, I'll try my best to deliver my presentation through the Google Meet, this platform. I do not know how much I'll be able to be successful. In case of any technical glitches, I would apologize at the beginning. Please bear with me, and we'll try to fix the technical glitches and then move forward. So I will have the two session. One is exactly 10 o'clock to 11:30, and then 30 minutes gap, and then I guess 12 to 1:30. And practically we'll try to utilize as much as possible. So bear with me if my talks are redundant to you, or if my concepts are not acceptable to you. You can always mail me, you can always give me your message on my WhatsApp, and we can definitely collaborate. Uh, Thanks to Ranjita ma'am for the introduction. I'm still a learner. I haven't achieved really anything in my life. I'm still a learner. I'm really fortunate enough, because I have my scholars, I have my students who really contributed, and because of that, I'm very happy to announce here I was listed in top 2 scientists of the world by the Stanford, recently in the Stanford list of researchers in the world. And in AI, my rank is 3,000 plus among 2,15,000 plus scientists in the world. And this all credit goes to my scholars and my colleagues, my friends, and my collaborators like you all. Individually, I'm zero, but collectively, we are able to do something. So, with that submission to you from core of my heart, I would like to proceed with my discussion for two sessions today. So, if any time you feel any discomfort of bearing with me or my voice or my presentation, you are free to leave the session with the permission of the authority, or you are free to join, or if any difficulties, you can definitely interrupt me. I would love if you can ask me after the session so that we can have more interaction and my flow will not be missed. Thank you. Thank you. With this, let me carry on. Now, uh, I understand. I guess most of you must be well aware of this machine learning, or you are well aware of uh, neural network, um, soft computing, things like that. If not, if not, then I can confidently tell you, if this is your first time, or if you haven't done any work on machine learning or things like that, then I can confidently tell you that this session today, which I am going to present to you, will be an eye opener for you in your work, in your pursuit of your research in the future. So I would coin my talk in a different way. I will not go the way I have been asked to go, neural network, then immediately go to the deep learning. My as a teacher, because I am 33 years of teaching experience, particularly in undergrad and postgraduate students in India. So what I would I like to have a foundation first. I would like to create a need first. Why do I need this? Because unless a necessity is there, you cannot really invent anything. So somebody has said necessity is the mother of invention. So let us create the necessity. Why do I need this? Why do I need because I have so many kind of algorithms available in my computer science. I call them as traditional classical techniques, classical algorithms. Why do I want some kind of not traditional or alternate way or out of the box type of stops for my work? So let me set a base for this first, and from that base let me create a necessity, and from the necessity let me take a baby uh, step up the ladder one by one, and climb the ladder as much as practically possible in today's two session. But definitely I'll be unveiling the mystery of neural network and the mystery of the deep learning today in these two sessions. So let me straight go to my presentation. Bear with me for some time, and help me if it is coming or not coming, because as I said, um, now I have to see how to share this. I need to share my screen. Uh, Anything visible? Can anybody?
Yes, sir, it is visible.
What is visible?
You are presenting. The
No, no.
screen is,
My past PPT visible?
no, PPT is not visible yet.
Okay, that's what I wanted to check. Please bear with me, because I said I'm first time doing this. If you can help me how to, where to go and do. Sir, I guess once you present the PPT, no, so there are two different, pages will come. One on PPT, another on your own screen itself. Okay. I mean, you need to have two things open. Yes, yes, yes. That's okay, what I'm trying to say. Let me see. Yeah, yes. I have made my first this PPT open. Then I'm going to the present now. Then yeah, shall I click window or entire screen? You can click entire window, but then there'll be two different windows. One is your own screen, other is the shared presentation.
Entire screen.
Sir, entire screen. She's saying. Are you able to see any presentation?
Yeah,
it has started coming, sir. Yes, it has started coming.
Thank you, Dr.
Just confirm me.
Nice introduction. Thank you for inviting me to give a keynote.
If you are able to see my past presentation, past slide, just confirm me.
And I thank also Dr. Ripan.
No, sir, not as of
No,
now.
sir. It's a blank screen, sir. Black screen it is coming.
It is coming black screen.
Have you done entire screen? Entire
No,
bit.
I did. Okay, let me go for entire screen now. But the entire screen, that my screen is not coming. Uh,
The pop-up tab which is open, sir, click on that screen, and it will make the share option blue. So click on that screen.
uh,
Yes, sir.
Now
Yes, sir. Now it is visible, sir.
it is coming.
Yes, sir. Now it is visible, sir.
Now, are you able to see my first slide?
No.
Sir, just go to the minimize Chrome and open your presentation, sir. Yes, sir. Now it
Yeah,
is visible. Yes, sir.
my first
Visible, sir.
screen is visible, right?
Yes, sir. Yes, sir.
I have written computational intelligence for intelligent system design.
Yes, sir. Yes, sir.
Okay, so suppose I now go to the next one. Next one coming.
Yes, sir. Yes, sir.
Okay, so shall I
Intelligent
go to
system.
the slides?
Uh, yes, sir.
Yes. Now put it in slideshow mode.
Yes,
Okay,
sir.
Yes.
it is
Yes,
okay.
sir. Yes, sir.
Yes.
Okay, okay, fine. What you see now in the screen?
Sir, it is blank screen with the slide background.
Okay, it's a backdrop. And do you see something in the backdrop? Yeah, somebody said handshaking, right?
Yes, yes, sir.
Okay,
Sir,
fantastic, very good. Yeah, you're right. I just purposely did this background that there is a handshaking. And secondly, are you able to see me, my face?
Yes, sir. Very
Okay,
clearly.
very good. Thank you very much. But I can't see anybody. This is a blank screen for me. I mean, I don't see any participants. So, all right, because in Zoom I could see, right? So, doesn't matter. Anyway, doesn't matter. Let us solve the purpose. Doesn't matter. So, fine. So now this screen, which is a blank one with a handshaking, with a button, one hand someone, other hand somebody. So there is a purpose for this, and in due course of my presentation, please remind me to tell the purpose because there is a beautiful purpose for this. Fantastic. So let me go ahead with my presentation now. So I have chosen my topic heading for today's session. Both session is computational intelligence for intelligent system design, and my university I work with KIT deemed to be University Bhubaneswar, and my mail ID is given, and my phone number is my WhatsApp number. You wish to communicate with me in future, you can do so for our mutual benefit. So handshaking, for our mutual handshaking, you can do so. Fantastic. Now you can see there is two different terms in this title. One is intelligent system design, other one is computational intelligence. So let me come to the second term first, which is intelligent system design. Why I have chosen the term intelligent system design? Probably you know what is a system. You know, uh, I will be happy if you can make your mobile phone little, this mode so that it doesn't disturb all of us. Thank you. So, what's a system? System, I think, is is very overused, used, abused, misused technical word in our technical lexicon. Particularly in engineering, the system is an overused word. You call it biological system, nervous system, you call it this system is not working, communication system, computer system, so on and so forth. This system is the word which is really abused rather than overused in my term. Similarly, we have an intelligent system. So what is a system? System is collection of different subcomponents or components in a particular fashion so that it solves one desired objective, a desired goal. That's what we call it. It's a system. For example, a nervous system. We have something connected so that we breathe. digestive system. We have certain things connected in our body so that our food gets digested. Communication system, you have base station, you have land station, you have your mobile network, you have some connection, some protocol, so that you are able to communicate with your near and dear one. That's called a system. So similarly, we are talking about intelligent system. We almost everything today are all intelligent system design. The entire research fraternity now moving towards intelligent system design. Doesn't matter whether they are civil engineers, they are mechanical engineers, they are from the humanities or sciences, or they are from the management, or they are from the social sciences. Everybody would like to have some automated system. We like to have one autonomous automated system which does the work like a human being is doing, the way I am doing, because human being is considered as the most intelligent entity in the world. How to define the intelligence is definitely very difficult. If I ask you define intelligence in this forum, I'm sure many of you will be able to give me many different definitions, your own perception, your views about what do you mean by intelligence. I think in India, we always consider Swami Vivekananda is one of the most intelligent saint. I think everybody will agree. There is no disagreement in this. He has the huge wisdom, and he is considered as one of the intelligent person. I have read somewhere. I have also heard somewhere a beautiful incident. When Swami Vivekananda went to US for his studies, whether it has really happened or not, I do not know. It might be a fiction, it might be some kind of creation just for understanding what is intelligence. I am putting forward to you. So he went to US for doing his studies, and he was known to be one of the most intelligent person. And the teacher, the professor, he was very uncomfortable of considering a student being more intelligent. He thought the teacher is most intelligent, student cannot be intelligent. Hopefully some of us might be thinking so, that the speaker is more intelligent than the listener. You will see from the summary of the essence of this story that it is wrong. So the teacher considered that I am the most intelligent, the Vivekananda is not intelligent. So he wanted to make one kind of questionnaire to him. Then he said that Vivekananda, people they say that you are most intelligent, and I would like to prove, I would like to taste that statement. Are you ready? Vivekananda, with all politeness and humbleness and humility, said, yes, yes, sir, I'm ready. Then what did the teacher do? He kept some amount of money, the dollar, and so many books, notes, reference books, textbook in the corner of the house, and then the classroom, and then said, Vivekananda, go and pick up. Then Vivekananda went and he picked up the money. When he picked up the money and came back, the teacher really got astonished, and he was surprised. And he said, what is this, Vivekananda? You are termed as one of the most intelligent personnel in the entire planet, entire world, and you have picked up money instead of books. Books is the knowledge. Books are the information. Books are the wisdom. Why did you do so? If I would have been asked this question, the teacher is saying himself, if I would have been asked this question, I would have definitely picked up the books, not the money. Then with all politeness, then the Vivekananda replied, yes, sir, you are true, you are correct, you are 100% correct. You pick up those which you do not have. You pick up those which you do not have. I had enough knowledge, so I picked up money because I had no money. And you do not have probably the knowledge, so you picked up the book. So what is the intelligence? Intelligence is out of box thinking. So this is one of the definition of the intelligence, out of box thinking. Intelligence is replying at the right time, the right answer, maybe the intelligence. So over the years, people have started discussing how to design the intelligent system. Now, this lecture will be part of how to design the intelligent system for any system, not necessarily computer science. Maybe I am belonging to the computer science branch, but my talk will be generic, and how to design this intelligent system using a term called computational intelligence. I have taken this term and I'll be defining defining this term because you have understood AI. Many of you know artificial intelligence. Then why did I come with one term called computational intelligence that I'm going to definitely put forward today in our presentation. Let me go ahead. If I want to design intelligent system, the first question will come to me: what are the things I need? This is very generic, my dear young friends, or my dear all friends who are here. This is very generic, and if it is not acceptable to you, that's all right. But I have learned it, and I have heard it, I have been taught, so I'm presenting that. What are the different stages I need to design intelligent system? Doesn't matter. Intelligent system is for electrical or mechanical or any engineering, computer science, or even social science and humanities or mathematics. So let me see what are the methods. Number one, for designing the intelligent system, I need sense of the world, sensing the world, taking the input. I need input. If I don't have input, I really cannot do anything. So first of all, I have to think about the input. Where from I am getting my data? Where from I am getting my raw materials? Where from I getting my input ingredients? And that is called sense the world. You need to sense the world. Sensing is inputting. My body having a lot of biological sensor. My eyes, my nose, my ear, my mouth, my hand, my skin. These are all different type of sensors. I call them as biological sensors. They take some input from the outside world. I can touch somebody and feel the temperature. I can smell something. I can see you. I can listen. These are all the different ways I am taking the input to my body. I can eat something. This is also one of the element from which I can take the input. So I need to know the sensing of the world. How do I know? How can I do this? What technique I have to follow? There are huge number of techniques available in our literature of the machine learning and computer science and all, but I have just presented a couple of those. One is DSP. Many of you, those who are from electrical and electronic sciences, they must be knowing something called signal processing, digital signal processing. So I must learn DSP if I want to design intelligent system. Or image processing. I have to take one image and take the feature or filter it, crop it, enlarge it, segment it. So many kind of stuffs I need to know in image processing. Then I can take my required inputs. See, I don't eat everything. I don't smell everything. I don't touch everybody. I touch the relevant information, the relevant data. That's why I need to have some kind of filtration, some kind of segmentation. I can't just take garbage. If garbage is in, garbage will be out. Gigo. So I need to see which are the relevant information for you. Today I am only giving lecture to the relevant people because 150 people only were selected or they have registered. I'm not giving it to some billions of the people of the world. So those are relevant to me and I am relevant to you. So I need to know what are the relevant data, or I can have some statistical data collection techniques. So this is the first and foremost thing, my dear friends. If you want to work on machine intelligent design, then you must first focus on sense of the world. Next, once you have senses, you have taken, you have to also have information extraction, because you can have all those data, but data may be redundant, data may be noisy, data may not be sufficient, data may be inadequate, data may be inconsistent, data may not be relevant. So, and I need to extract the information. I don't want data. Today we are all data rich but information poor. If you see my backdrop, I'll have so many books. Those are data, but hardly I read them. Hardly I extract anything from that. And that's called information. So I need to extract the information about the world. I have sensed the world. After sensing, I have collected the data. From the data, I need to take the information, and you will find out the term, the technology which we are going to discuss today is there, called a neural network. It is there. So neural network is some way playing a big role in extracting the information. If you have a huge amount of the data and you have to take the information, then I have to go for the neural network, or maybe feature extraction, deep learning, which also a part of feature extraction. So today's topic is now centering around this second concept, second stage, extracting information about the data. And apart from that, we have fuzzy learning, we have data comparison, and many others. I have only listed a few as an illustrative purposes. So second aspect is data collection, and second aspect is extraction of the information about the world. Is that enough? No. After extracting the world, what you need is recognize the state of the world. Recognize the state of the world. All you have extracted, that's fine. But what kind of recognition you are doing? And again, we have neural network there. We call neural network as pattern recognition. I have used initially neural network for extracting the information. Now, next I go for pattern recognition, because that is how the intelligent people, they do the work. Pattern. We all human being, we never learn any word by letter. We always learn by word by pattern. We remember somebody by looking at the face. We understand or recognize some voice by listening their voice. We create a pattern in our mind. So pattern recognition, pattern classification, the most important part from which you can understand in which state of the world my data is there. So I can have many statistical technique, I can have many detection theories, so many stuffs will be available in our recognizing the state of the world. That's the third thing, and you can see that neural network is there. And today in my talk, I'll give you fundamental of the neural network, and then I would also try to give you an application of the neural network for pattern recognition, so that you can understand the second and third step. Fourth one is, I have done first three. Then fourth one is that enough if I recognize the world? No, I also have to predict. I have to also have to predict the behavior of the world, because intelligent system will always do the prediction, forecasting, assessing the future. If you are intelligent teacher, you will always tell your student, hey, do this, otherwise you may not pass. Don't do that, otherwise you will have a trouble. If you are not able to do this, you are not an intelligent teacher. If you are an intelligent teacher, you must predict the behavior of your disciple. You must predict the behavior of your student. You must do kind of prognosis and then forecast. You can tell that this is going to happen, so that the boy or the girl will change himself. So this is very important for our applications, and for that reason you have weather forecasting, you have earthquake forecasting, you have stock market forecasting, you have bullion forecasting, you have egg forecasting. So many type of forecasting models are there. Forecasting is very important. Telling prediction is very important. Now you go to a doctor and doctor prognosis and says, hey, do this, otherwise this may happen. So what do I learn? How do I do it in my intelligent system design? Maybe I learn probability theory, Bayesian probability theory, Bayesian theorem, deep belief network, probability theory, or maybe I do some kind of time series analysis, ARIMA, ARMA, all that, time series analysis, because the data will be in the time series, or I have some kind of dynamical system theory. So many other stuffs will be available in predicting the behavior of the world. So friends, you have gone from the first stage to the fourth stage. Now you have predicted. You must be thinking my job is over because I have predicted. No. No. When you predict it, people will ask you, what is the guarantee? Why do you say this? Why should I accept you? You know, people will not take, so whatever the presentation I am doing today, certainly you will be questioning me. Why, sir? Why this? Can you give any reason about it? Reasoning. Because we are all, the system is that we are all reasoning in mentality. We are all rational in mentality sometimes. So we always have a kind of if-else statement in our mind. We always like to see why, when, how, what. These are all the type of question we always ask. So we always reason about the world. And once you reason about the world and get a satisfactory answer, then only you can plan action. When doctor says this may happen, you blindly don't accept it. Probably you will ask, why do you say this, sir? And if doctor is able to provide you some evidence in terms of the clinical report, and then justifies, you accept. And once you accept, then you ask, sir, what should I do? Plan of action. There comes the plan of action. So reasoning about the world is very important. Today people, they forget, they predict, they go away. No, you predict and you tell. Why did you predict so? If you say you're a student that you might not pass if you do like this, the immediate question he will ask you, why did you come to this conclusion about me? Sir, can you justify? And if you have some justifications, if you are able to present it through the visualization tools, there are a lot of visualization softwares today, Tableau and all softwares are there, you must be knowing. And most of the business houses, they always depend on this, because that is what you are called decision making. You can take a decision only when you reason about. And that is what your artificial intelligence is about. My machine will do something provided it has sufficient reasoning, and then it will plan action. So the fifth stage is reason about the world and plan action. So is it enough? Is this over? Probably not. We are left with the last one, and the most important one is your um, is your act on, communicate with the world. You have taken the input, you have extracted information, you have recognized the state of the world, you have predicted the behavior, you have done the reasoning. Once all these five are over, the next thing is, let's do it. Act on. Let's do it. Let's implement it. Let's deploy it. Let's communicate to the communication world. Let's create one app, Android app. Let's create a web page. Let's have user interface. Let's have menu. Let's have form, so that outside world can really use it. If I know I cannot communicate to you, hell with my knowing. If I have done lot of research, but I really cannot present to you, communicate you, make you understand, hell with my research. No use. Many times you have told your student, hey, you know, but you cannot express, it will not be done. Why? Because communication with the world is more important. Only when you communicate, the benefit will pass on to the society. Every research should have a societal benefit. Very recently, me and my 2-3 of my students, BTech student, we have developed using deep learning. If possible today, I'll show you that model using deep learning, checking the malaria parasite. Checking the malaria, whether you have malaria or not on the blood, is a very tiring and cumbersome process. Since you need to count under the microscope 5,000 number of WBC and RBC, taking the blood smear on a slide, which is very time consuming purposes. Today you give, tomorrow you come back, and there may be error. We have come out with a very new tool. Anywhere in the world, any remote corner, you just take a blood, put it in a piece of paper, take a picture, image, and upload that image to our app. We have developed the app. We have also the website jike.ml. That website is there. We had a support from the Stanford as well as Amazon for developing this. And Chhattisgarh government now has asked us to take this patent, or they want to deploy it. Because any corner of the world, it takes fraction of the second for checking this, whether I have malaria or not, with 98% of the accuracy. 2% we failed. However, 98% we own. And this is called giving back to the society, communicating with the society, acting on. So any research which you do must ultimately pass on to the society. And for that, you may have information communication theory, you may have website designing, you may have Android, you may have control theory or robotics, so on and so forth. So these are the 6 steps which I have to go through when I would like to design any intelligent system. And in this 6, you will find out that my today's topic is predominantly present in 2 of the states, in the 2 of the stages. And my predecessors 3 days before or maybe tomorrow, they might be talking about few of these in their course of discussions. I hope I am able to communicate. I'll just like to cross verify from my participants whether my flow is okay, my speed is okay, and I'm able to convey the information so that I can move on to my next slide. Anyone?
Yes, sir. Very nicely conveyed.
Very nice, sir.
Is it okay? Fine. Thank you. Thank you.
Yes, sir.
So because I'm basically a teacher, so as a teacher, the way I teach in the class, the same way I'm giving it. I'm not giving like a researcher, just move the slides and show the big diagrams and equations, and finally uh, confuse the audience. I don't want to do it. Whatever little I know, I'll go with a very solid and very slow, with your permissions. Right. Now, if this is their intelligence system, then what you are gathering from this 6 points, that I am dealing with data. Am I right? Everywhere you see the data is my, what you call, essence. Starting from the first step to the last step, you see that I'm only dealing with data. Maybe technology is there, maybe model is there, maybe algorithm is their background, but ultimately I'm dealing with data. So it means my at my disposal lot of data there. So it means for me it is a big data, picture of big data. You are talking about today big data. Many of you must be working on big data analytics. You call it as a big data. I don't see big data analytics in that perspective. I see in a very simple perspective, which I'll be presenting you in my next slide. My perception, what is big data? My perception, what is data analytics? My perception, what is decision science? My perception, what is data scientist? My perception, what I understand out of my experience of teaching and out of my experience of working. I first understood that in entire my life, I'll be dealing with data only. Doesn't matter what is my algorithm. It may be fuzzy, it may be neural network, it may be regression, it may be SBM, it may be principal component analysis, it may be decision tree, it may be neural network, it may be CNN, it may be GAN, it may be quantum computing, it may be anything. Data is my prime requirement, and every time I'll be dealing with the data. It means I need to understand data very well. Understanding data is really very tough, because data changes its meaning over the time. Now you may ask me, sir, what do you mean by this? How can data meaning change over the time? How it is possible? How can over the time the data meaning changes? It is not time dependent. You may argue with me. I'll give you a beautiful anecdote which I have heard from a great saint and philosopher. I can say. I think you must be knowing. You must have also be a follower of him, Guru Gopal Das. So Guru Gopal Das, one of the stop I heard, one of the presentation, a lecture I heard, and I would like to quote that here. And it is very much befitting that why the meaning of the data might change over the period of the time. Why data is like a time series. It changes its meaning. It so happened a 3 years old boy, 3 years old boy, went to his mother and said, "Mama, I love you. Mother, I love you." This is the data. Mother, I love you. Mama, I love you. And mother is understanding it and saying, "Son, I love you very much." The reply, understanding me, the meaning of Mama, I love you, replied it. Now, 3 years old boy has become now 16 years. 16 saal, 16 years. And then he goes and says, "Mama, I love you." Now, mother listens the same data. "Mama, I love you." But now you see the meaning, interpretation is different. Now she is interpreting in a different way and answering, "How much of money you need, my dear son? How much of money you need, my dear son?" 16 years. 3 years to 16 years, 13 years passed. Same data, information meaning is different by the listener. Now 16 years has become 25 years. Boy, he goes and says, "Mama, I love you." Then the mother is replying, "Who is that girl? Who is that girl?" You got 25 years. So mother is understanding in a different way the same sentence. Data remains the same. Time changes, interpretation changes, meaning changes. Now 25 years young lad, now is 45 years. 20 years past, 45 years. And goes and says, "Mama, I love you." Now mother replies, मैंने बोला था ना उस लड़की को शादी मत करो. Didn't I tell you that don't marry that girl? Look at the understanding. At 45 years, the gentleman is coming and saying, Mama, I love you, instead of saying, Honey, I love you, to his wife. So, कुछ तो गड़बड़ है दया. दया, कुछ तो गड़बड़ है. Something is wrong. Now, mother is understanding that, okay, maybe some kind of, differences between the spouse. And that's why this fellow has come back and saying. And this 45 years story is not ended here. The 45 years now becomes 65 years. And comes and says, Mama, I love you. Then mother is alive by God's grace. No COVID. Mother is alive. Now mother is replying, I am not going to sign on the property paper. I am not going to sign on the property paper. My dear friends, can you see the different interpretation of the same data? Yes. Different interpretation, different meaning. From 3 years to the 65 years. The same data now has got a different meaning. 10 years back, internet had a different kind of meaning to us. Today, internet has got a different kind of meaning. 10, 15 years back, the mobile phone was a different meaning to us just for calling. Today, mobile phone is everything. 10 years back, Google was a different thing for us. Today, Google is my baat. Google is everything for us. 10 years before, online transaction or online mobile financial transaction was something different. Today, it is different. So, what I mean to say is, data really changes its meaning over the time. And all applications are today data intensive applications for that reason. And this is my understanding this slide. That every application you do today, every intelligent system you design today, every kind of research you do today will have these 5 stops, more or less directly or indirectly. Somewhere you have a hindsight. What happened? You investigate what happened. What happened in my system? You go to a doctor, doctor first investigates what happened to the patient. What happened? Descriptive analytics. You are describing. You are asking required questions. You are trying to understand the system. What happened? That's called a hindsight. Then once your hindsight is over, you go to see what is happening. Oversight. What is happening? Why did it happen? Diagnostic analytics for any system. Diagnostic analytics. And once you have hindsight and oversight fulfilled, you come to the next one called foresight, future, prediction, predictive analytics, foresight. You are talking about future, prediction. And once that third thing is over, you go for optimizing. You are trying to optimize, how can we optimize what happens? Like a doctor says, okay, if this happens, then this can be optimized. You take this medicine, that medicine, prescriptive analytics. The doctor writes a prescription. Insight. That's called insight. You're looking at through the, kind of microscopic eyes and then writing the prescription. Doctor writes insight. And finally, the most important one, the 360-degree view. Right side. Right action, right decision, right time. Within the specific context, of course. Because everything will have a context. You can't generalize it. When I am prescribing for cancer, I would have a cancer as the domain context. If it is for malaria, the malaria as the domain context. It is for COVID, the COVID as the domain context. The data I am dealing with is the for COVID context. For example, chest X-ray. We have worked on COVID-19. We have now excellent 3 papers published, and another paper will be published very soon, all in the SCI Index Journal. So we have made some kind of deep learning framework. for the chest X-ray, and then trying to differentiate between normal pneumonia and pneumonia due to the COVID-19. So it is a right side, the 360-degree view. So five thing I understand when you design any intelligent system, the five things necessary, and somehow or the other you will find out your neural network is there, your deep learning is there. Friends, I'm just going slow because I want to have a base for why should I learn neural network and deep learning. Not because it is available in the Atal FDP I should learn it. I must have a basic foundation first, the need first, the necessity first, then I should go for. This is how I teach my class. I first set a need. Why should I read computer architecture? Why should I read microprocessor? Have the base, then shoot up. Then people will definitely have some kind of interest in this. So I'm just trying to create that kind of setup here, that I need 5 stops in my data intensive applications. Let me move ahead. If I do so, if I make intelligent system design, how does it really help me? Really, will it help it? I predominantly work on AI for medicine. All my works are on the medicine. You can Google and you can get all my recent publication. This year about 20 SCI journal I have published. So all are in the AI for medicines, particularly for the medical scientists, right, doctors. So this is one example where I have taken. The left hand picture of your screen is the one, your MRI brain scanning coming from the MRI machine. The right hand picture of your screen is coming the same left hand picture through certain automated feature extraction. Maybe deep learning, maybe neural network, maybe any other technique which you know. Look at the difference. The region of interest, ROI, the region of interest is clearly visible on my right hand screen, on the right hand picture. Yes, for an expert doctor, maybe the left hand screen is good enough because the doctor is looking at, but doctor is a human being. Doctor has got emotion. Doctor has got a wife. Doctor might have a tussle with his wife in the morning. Doctor has got a son. Doctor son might be reading in PVAP SIT. And Doctor son might not be understanding the project given by Vijay. And Doctor son might be doing some mistake. And teacher might have called the doctor and said your son is not doing well. So doctor might be little stressed. And when a patient comes with this left hand picture, doctor might do mistake. Might. There is maybe some percentage of error. But when it is presented with the right one, despite all his stresses, because there is some clarity, hopefully, I am telling hopefully, because I can't replace the doctor's view, decision. Hopefully, doctor might do some correct, might take some correct decision. This is called the intelligent system design, augmenting the doctor's hand by designing the neural network based or deep learning based concepts. What exactly happening in that? If you look at the input space on the top diagram, left side, the first one, and there are some red dots and blue dots. If you look at the input space in that particular dimension, you see everybody in the same plane. But when that input space is mapped to a feature space by automated software, by extracting the pattern, you remember I have told you extract the information using pattern recognition technique, create pattern matching using neural network. And if I can differentiate, okay, below that plane, the green plane, my red, above that green plane, my blue, I can visualize it very nicely. A human being can visualize in the naked eyes. However, the previous one I cannot. So there is a mapping input space to the feature space, and that mapping is done by some sort of feature extraction techniques. It may be principal component analysis, it may be independent component analysis, it may be your neural network, it may be your CNN, it may be your generative adversarial network, or whatever. I am just mapping it. Similarly, if I see the right hand corner, right side bottom diagram, there is some kind of regioning. We have a regioning in the 6 steps which I have shown you. And it is a diagnostic reasoning. And you are coming out, well, I'll go to the hospital provided I have BY, I have PI, then only I'll go to the RI. So any person will be hospitalized, any NI will be hospitalized, provided he goes through some arrows. If he has pi and pi leads to VI, VI leads to PI, then he will be admitted in the hospital. Such kind of reasonings are there. And these reasonings can be designed by you and me in terms of the software, in terms of our system designing. I think we can definitely aid or support our society and medical system. This is just 2 slides which I have shown you for supporting my argument that there is a necessity of ML based, computer based intelligent system design to augment the doctors or the decision scientists in the world. Doesn't matter which branch they belong to. And it has got many applications. So I call those are machine learning. I am making my machine intelligent. I am making my machine learn. And because of that machine learning, it can control many applications. It can control many applications. For example, weather and natural disaster predictions, speech and image recognition, biomedical imaging and diagnosis, manufacturing and robotics, automotive system, stock market and economic predictions, aerospace system, electromagnetic devices control and optimization, computer games and virtual reality. My dear young friends, all the friends over here, you can find out that many of you, rather all of you, must be working in some area or other, whatever I have presented here. It has got innumerable applications in the world. I have just listed a few, and that's called machine intelligence or control applications. It just name a few. You can design, you can use your neural network for such kind of applications. Let me move ahead. So, agriculture, genomics and bioinformatics, industrial optimization, anywhere you can call it. Now, I come to computational intelligence and soft computing. I have used a term called computational intelligence. And also, many of you must be having another term called soft computing. These are the basic bookish definitions. It's not my definition, bookish definition from Wikipedia, which I have extracted to present here for the people who are first time encountering this. Those who already are working, please bear with me, because we have a heterogeneous mass. So what is computational intelligence? It's a branch of study of AI. So it means CI has come from the AI. It is a branch, CI is a subset of the AI. It is a branch of study of the AI whose aim is to learning, adaptive or evolutionary. It will learn, it will adopt and it will evolve. Like a human being, like our brain. We learn something, then we get adapted to that, and finally we try to evolve. My teacher told me in my school days, A for apple. Trust me, she has never shown me any apple. She has not told me the color of the apple. She never shown me whether the apple belongs to Australia, America or Kashmir or Himachal Pradesh. She has never given any apple to eat to me. She had apple in her lunchbox, she ate only. But today, I know what is A for apple, and I know different type of apples. She only told me A for apple. She never taught me A for aeroplane, A for ant, A for adaptiveness, A for attitude, or A for so on and so forth. How did I do it? Because I have adaptive mechanism. I am adaptive in nature, and I am evolving in nature. I am evolving, progressing. So I created some sense of intelligence in my brain by learning. My human brain learning is by listening, by doing, by practicing, by following, by committing mistakes. This is how I learn. And I learn by pattern. I don't learn by alphabets. I learn by pattern. So through that I am doing, and that is what called computational intelligence. It deals with the study of adaptive mechanism which allow the simulation of the intelligent behavior in any complex or dynamic environment. Very important. Intelligent behavior, simulation of intelligent behavior. And because of the intelligent behavior, we adopt ourselves. Last 3 days you were listening to different talks. You adapted yourself to the speaker's voice, the speaker's speed, the speaker's pronunciation, the speaker's way of presentation. And today you are listening to me. And I'm sure initially you might have some kind of difficulties, but later on you are now adjusted to me. You are I had difficulties in talking to a screen, seeing nobody. I felt little discomfort for past 5 minutes, but now I got adjusted. Yeah, this is my life. This is my session. I have to go on, and that is called your adaptive mechanism of a human being, and that is your computational intelligence. You are computing it, and how you are computing it? By adoption, by learning, by evaluation, and that is what we'll see neural network is doing. That is what we'll see deep learning is doing. When I teach neural network, I'll tell that it has this adaptive mechanism, and then you refer to this discussion which I presented here. Other side is soft computing. What is soft computing? Collection of some new techniques in computer science, particularly in AI, which is not hard computing. Hard computing, soft computing. Hard means very precise, 0 or 1, tall or short, dark or brightest, good or bad. This is hard. Hard computing 0 and 1. Soft computing is little bit of fuzzy, uncertainty, imprecise, partial truth. That's called soft computing. And entire world is partial truth. Entire world is uncertainty. There is nothing called the brightest and the darkest. There is nothing called the tallest and the shortest. You say that boy is taller, more taller than shorter. This air is more cleaner than dirtier. This boy is more fairer than darker. So you use always these linguistic terms. You have all this kind of linguistic reasoning in your own natural language. Now how do I map it to my machine? Because my machine is digital. Von Neumann has given you the digital computer, which will work only on zeros and ones. It will work on hard computing, either this or this. It will work on atomicity of your database property, acid property, atomicity. Either I'll do, otherwise I'll not do. But no, my world is full of uncertainty. My world is full of impreciseness, partial truth. How do I deal with this? So I need some kind of soft computing, and our brain is one best example of this soft computing. Because our brain never decides with yes or no. Our brain always decides with some kind of approximation, some kind of mapping function. Our brain works on some kind of membership function, in other words, in fuzzy logic. And our brain is able to exploit the tolerance. It exploits the impreciousness, uncertainty, partial truth, which to achieve the tractability, the robustness, the low solution cost. This is taken from the Wikipedia. That's called the soft computing. I am able to do it. I know how to do best so that I get the highest return on my investment. I may accept something, I may reject something. So that is called the soft computing, and neural network and deep learning are the part of also this soft computing. Soft computing and CI are the part of AI. So we are moving slowly towards that. This picture, this slide will give you a clear indication of what are the component which I need to we need to implement in my intelligent system design. What are the algorithms and from where they are inspired. For our story, for our session, because it is neural network, I'll only limit to the neural network. So neural computing, my main computing is neural computing. It means I must mimic my brain, neuron, human brain. And for that, what technique tool I need? Artificial neural network, ANN. I need that. And how, from where they are inspired? They are inspired from the human brain. So neural network is the inspiration of the human brain. It is the mimicry of the physical human brain. do the job the way human being does the job. That's called artificial. I call that's why it is artificial neural networks. Why it is a network? It is connection of several neurons in the different layers. That's why it is a network. Connection of a lot of networks. Interconnection of networks. So it is artificial neural network. And the component, we call it a neural component. We have evolutionary computation, next one. Evolution. Then we need to, the tools are evolutionary algorithms. I am sure some of the evolutionary algorithms might have been taught to you. Evolutionary optimization techniques like genetic algorithm or evolutionary computation or differential evolution, particle sum optimization, so on and so forth. My actual domain of work is evolutionary computation. I mean, presently I am focusing more on this. And I would like to present to the entire audience that I have developed to my own algorithm in the world, like GA and PSO. I am the inventor of the two algorithms. One is called social group optimization, inspired from the Vivekananda's life. Social group optimization, freely available this paper. You can download, and my course will be free to you if you want to use it. It works fantastic. It became the world's fourth best algorithm in 2016 coding competition by IEEE in China, and by my first PhD scholar who got gold medal because of that work. SGO, social group optimization, we have developed. 2017 we developed one more called SELO, social evaluation and learning optimization. With my collaborator from Canada and from Pune, we developed SELO. And that is inspired from the family, how the family to other family they interact, how the children they interact with the parents, how the parent interact with the other elderly members of the other family, how the siblings of this family interact with the siblings of the other family. We mathematically modeled it, and then we published it in first one we published in Springer, second one we published in Elsevier, and it really works fantastic. It works fantastic. And these are biological evolution, societal evolution, nature evolution, nature inspired kind of stuffs. Hundreds of algorithms are there. Third one is granular computing, regioning. You don't see everything as 0 and 1. You see everything as a partial truth, uncertainty. And techniques is Fuzzy set, Rob set, probabilistic regioning, nutrosophic set people are nowadays using. And the inspiration is human reasoning, natural language. You always say, oh, I like this boy better than that boy. What do you mean by better than that boy? How do I really encode it in my machine, in the intelligent system? Because my machine understands 0 and 1, best boy or worst boy. 1 is best boy, 0 is worst boy. How do I give better boy? How I do say, oh, today I am feeling little cold, and today's temperature is little chiller than yesterday. What do you mean by little chiller? The one little for you may be severing, for me may be lot of work. So how do I really do it? So CI, computational intelligence, covers all branches of science and engineering, my dear young friends. All branches of science and engineering that are concerned with understanding, solving problems for which effective traditional algorithms do not exist. Now slowly we are coming to requirement, need. Why do I need neural network? Why do I need fuzzy? Why do I need evolutionary computation? Answer is given in the red sentence. Traditional algorithms do not exist or not able to solve. I can't solve by my traditional technique, or it is not existing. How do I solve such kind of problem? So naturally I need some other methods. This is another way of presentation of that. We call it natural computing. Today we are not telling AI, we are not telling CI. Many of us, we are telling natural computing, inspired by the nature. We look to the sky. We see how birds are flying. We see how ants are moving. We see how termites are making the sand holes. We see how bees are making beehive. We see how ships are going, how snakes are moving, how germs are getting their food. We look at the nature. Looking at the nature, we get inspiration from the nature. And that inspiration, we convert it to a kind of computing. We call that as natural computing. natural computing. And neural computing is a part of natural computing. Because we are seeing the human brain. So we are inspired from the human brain and we are trying to create a mimicry of the human brain. We are trying to create a kind of short form of the human brain, a model of the human brain. We call it artificial neural network. So this is a natural computing. We call it as a natural computing. We don't call it any hard computing, soft computing. We call it evolutionary computing. My brain improves. At 3 years old, I was only knowing A for apple, A for aeroplane. But today I know many things without the teaching of my school teacher. So this is evolution. I have evolved. Yesterday I was not able to understand. Today I am understanding. Tomorrow I will be more understanding. So this is evolution. So this computational intelligence and the other stops are now moving towards the natural computing. So we are dealing with natural computing in our talk. This is the Amit Konar, a very good friend of mine, has given a beautiful classification of computational intelligence. So this is just, you can see most of you know all these techniques. Most of you know all these techniques. And if you see towards the right hand swarm intelligence, I work on swarm intelligence. Also, I have worked on genetic programming to some extent. And all these systems you know, I will not go through this. And this is another view of, again, computational intelligence. You can see that traditional AI is here, left side, the darker circle. And the other computational intelligence is coming this side, where GA, evolutionary programming, belief network, fuzzy logic, neural computing, evolutionary artificial life, these are all part of this. Slowly this area is evolving now. No, not the traditional AI. So once we have made this, now we are coming, why some problems are difficult to solve? Why can't I solve this problem in my traditional algorithm? Answers are there. Some real world problems, mathematically intractable. It requires a large search space. It may time vary. It has got noisy observations. Or it may have certain competitors. So because of this reason, actually some real world problems are really difficult to solve. I'll give you an example of the problem solving, and particularly the hard problem. What do you mean by hard problem? NP hard problem. I think most of you must be knowing what is NP hard problem. The problem which are hard, both human and the computer can solve. It can take a lot of kind of space, and we call those are the hard problem, computationally hard problem. And other kind of problems are there. A human can solve, but machine cannot solve. I'll call those as ill-posed problem. For example, a character recognition. You are signing, I'm trying to recognize. Machine may fail, I may pass. Face recognition, speech recognition. So I'm dividing the entire problem into two parts. One is called computationally hard problem. Machine can solve, human brain can solve. No problem. Like Shakuntala Devi, let Shakuntala Devi. She solved a lot of complex mathematics. Even computer also could solve. Maybe taking little more time, doesn't matter. But both can solve. But there are some problems. I call them as ill-posed problem. That will be better solved by human being, not by machine. Yes, I have to make my machine enabled by the different natural computing techniques, human-like techniques. And those are called ill-posed problems. Example of computationally hard problem. For example, I have a Boolean variable and I want to prove that this Boolean logic formula should work for all variables of n, very large space, because Boolean will have 0 and 1. If n number of variables in that logical formula, then I will have 2 to the power n subspace. I can solve it. It will take time. Traveling salesman problem. You all know this. We can solve it. It will take time. Exhaustive sorts we have to do. Computationally hard problems. They are called computationally hard problems. Now look at the ill-posed problem. I am giving you the two scenario. Number one scenario, first one. That in a company, I need to find out income of the employee larger than the average salary per company. What What is the average salary? I know. And I have to find out who are the employee getting more than average salary. Very simple. Select from where? In SQL. In SQL, you can write select from where. Simple. You are giving the predicate, condition, that salary greater than so and so. Select from your relations. Select the name, attribute from the relations, whatever the relational table you have. It will immediately throw you the answer. Very simple problem. But that is not ill posed problem. That can be easily solved by machine. Easily solved by machine. But what about the problem, the second category? Suppose in a company, now they decide who are the good candidates, good employees, so that a bank loan can be given and others who will not be given. I want to classify the entire employee into two parts. Who are the good candidates for whom I can give the bank loan and who are not? It's not that easy. You can't always go by the salary statement. You can't say, oh, this fellow is getting 5 lakh salary, let me give him this thing. No, he might have the bad credit history. Today, when you apply for any personal loan or any credit card, there is a CIBIL score. You know that, credit bureau. There is a CIBIL score. And the CIBIL, they have designed the algorithm based on so many characteristics. They have designed a kind of, a natural computing algorithms. They look at the entire history of yours and they come with one kind of figure of the threshold. And then they say, and despite that, even if your CIBIL score is bad, but a human being can take a decision out of his experience, a banker. It happened with me in way back when I was working in Visakhapatnam. When I applied for a home loan and gave the, I'm telling my life story, and gave 5-6 lakhs as the advance to the builder, and then applied for the home loan. The house construction is going on, and my banker all of one evening called me and said, when I saw the bank call, I was excited, my loan is granted. He said, sorry sir, we cannot give you the loan. I said, why? Because your CIBIL score is very bad. Probably, yes, I had some history of bad transaction with, through credit card. Some of them are waived out, some of them are pardoned. So then that created a very bad figure for me. And I was at loss. Oh my God, what should I do? Because 6 lakh I already paid to the builder, and as per the agreement, I will not get back any money, and I don't have the rest of the money to support from my own sources. I was completely dumb. Completely dumb. Then through some contact, I went to one more bank, and I presented my story to him, and I presented my present salary, this and that. You know what the bank manager did? He finally said, I'm going to give you after 2 days, 3 days, he called me, he said, I'm going to give you the loan. I said, how sir? I was curious. How did you decide this? Because my CIBIL score is bad. He said, CIBIL is history. History is past. Future is mystery. Mystery is future. Present is gift. Now I am seeing you the present. And you are gift to me because I see your credibility. I see you as talking to me. I find you are a good human being. So he utilized his own brain. This is the ill posed problem. He did not decide on the algorithm. He depended on the cognition. What is cognition? Is brain understanding. Cognition, neural network. Neural network works on cognition. It never works on algorithm. He mapped certain thing in his mind about me after talking to me, taking some data. He took some data for me. Last 3 days he ran it in his brain. I don't know what algorithm he ran. And then he came out with this answer, yes, you are a good candidate and I am going to give you. And trust me, just after 3 years, I repaid entire loan of that bank. I never breached the trust what he had on me, and I paid all loan in 3 years. Don't ask me where from I got the money, right? Income tax people will be after me. Jokes apart, ill posed problem. Ill posed problem cannot be solved by rejoining if-else statement. Sorry, it cannot be solved. It can be solved by experience. See the red one. Read from experience. And experience a bank expert takes for this example. He had some experience of the previous success or failure cases. And based on that, he took a decision. So neural network also works on like that. It is a function approximator. It will approximate. It will say from the history that yesterday this happened. So based on that, today I am saying this with this much of certainty. So he gave the experience. So well posed problem, ill posed problem. In ill posed problem, you should have some examples. What are the examples? The past data. The data can be incomplete or inconsistent, and traditional method cannot be applied. Ill posed problem cannot be easily formalized. You can't write one mathematical equation or a straight line or one nonlinear equation. Sorry. Because you can have some examples only available prior. Well posed problem, you can create a model. You can say, yes, this is my model. Based on this model, I am doing it. What is a model? Model is a straight line, y equal to mx plus c. What is a model? Model is a circle. A square equal to x square equal to x square plus y square equal to a square, a circle. So you have a solving method, an algorithm. And based on the algorithm, you are designing the solution, well posed problem. Ill posed problem, you don't have any algorithm. You have some data only. You have some examples only. And you have collected the data. You have to collect the information. You have to extract the feature. You have to do the reasoning. All those 6 steps, my dear friends, I told you. And sometimes it may be incomplete or inconsistent. Whatever the data you are collecting from the Google, do you think all those are correct? Might not be. But Google is my map today. All the data which you are collecting from the Google might not be correct. It might be incomplete, it might be inconsistent. But we depend on that. No, we should have our own judgment. So all ill posed problems, slowly I am coming to my topic. I'm sorry, I'm so slow. I have yet not come to the neural network, but I'll cover it up in my next session, of course. Because once you have a foundation, you can build your verticals. Now, ill posed problems. What I need when I am designing ill posed problem is a very important slide for you. What I need when I am designing ill posed problem. What I require when I am designing neural network, CNN or anything. Ability to extract some models from my example. I call learning. So my model should learn. Whatever neural network you are telling, it should learn. I am telling it should learn. Please focus this word, learn. Learn. And it should be adaptable. It should work on dynamic environment. Today it is dry, it will work. Tomorrow it is wet, it will work. Today 10 students I will teach. Tomorrow 100 students I will teach. Today I am not feeling well, I will teach. Tomorrow I am feeling well, I will also teach. Adaptability. I will not have my reasoning of not doing it. Third is most important one. It should be able to do work with noisy, incomplete, inconsistent data. Robustness. You can't say, no, my model will not work if the input is noisy. Finish. My doctor cannot say, sorry, you do not have this data. I can't really prescribe something to you. The doctor cannot be in the market. So doctor must be robust. Even if the X-ray screen is not clear, even if the CT scan report is not very much clear, or there is some kind of noisiness, incompleteness, doctor should be able to deal with this. That's called robustness. And finally, everything should be done in a reasonable amount of time. I can't take too long. If I take too long to talk to you basics, I'm sure everybody will just remove yourself from the Google Meet. I have to do it in the given time frame. If I'm not able to do it in the given time frame, I'm not efficient. I may be effective. I'm not efficient. I may be effective. So I need to see both things, efficacy or effectiveness and efficiency. Efficacy, effectiveness is the success rate in percentage. Efficiency in terms of convergence time. How fast I deal. And These things are possible if you employ methods from computational intelligence or soft computing. If you employ the methods from computational intelligence, soft computing, I am sure all these things will be possible. So, having made a foundation on this requirement of why should I go for neural network, why should I go for soft computing, why should I go for evolutionary computation, my next slide will be definitely talking about the neural network more. I will not come to this. My next slide will definitely talking about neural network more. I think it is 11:30, and our friends must be feeling little tired. So what I do is I stop presenting this, and then I just open to you for 3-4 minutes for any questions on this. And next session I'll go purely to the neural network and deep learning. Any questions, please? Feel free. I'm sure Ranjita ma'am must be having e-coffee and e-biscuit and e-tea for all of you. So if she can provide e-copy, will be happy. Anybody? Nothing? Yeah, some of you are giving me on message that you are appreciating. Thank you very much. If you can ask me on audio, I'll be very happy as well. Otherwise, we can again join after half an hour. Ranjita ma'am, are you there? Nobody responding. Hello? Anybody here?
Yes,
Ranjita ma'am here?
sir.
Yeah,
Yes,
madam.
sir.
We'll break for half an hour.
Yes, sir. We can take a break. It was a nice session actually. I hope everyone has enjoyed it. It was really good and lots of learning. And actually, it is from the start. And basic is it is good to learn how to build a model. It is not actually not good to learn